All right, let's begin because it's 7:10 already. Thank you so much, everyone, for joining in. I do see a lot of familiar faces from the last webinar, and I hope that you all liked the previous webinar and session where we discussed quite some things related to p values, related to a lot of other things in biostatistics, as well as in the session before that taken by Rajvi. You all also knew covered all the basics of biostatistics. So now in this session, we will bring all that together and we will see how to, where to apply tests, what is the difference between association, causation, etc. Essentially, this would be kind of like a, you know, big boss session in terms of biostatistics, where you will apply all of it right from, in fact, the first session you all attended, because the knowledge of study designs, etc., also matters a lot when choosing statistical tests and interpreting them. So without further ado, let's begin. I will share my screen. Rajvi, is my screen visible?
Yeah,
Yeah. Thank you so much. Also, it will be kind of nice if you all could, if everybody could turn on their cameras just for a more lively feeling, because I will be able to see y'all, so that will be great. No compulsion though. Okay. Uh, okay. So let's begin. Welcome. Okay. Welcome to this session on. Just give me a moment. I'm sorry. Yep. Uh, yep. Let's. I'm sorry for the lag in between. Yeah. So, welcome to the session on biostatistics part 2. And today we will go through a lot of concepts which you all might have been confused previously, and things like statistical analysis using computer software, which you all would have wanted to learn previously. So let's begin with understanding what is association, what is correlation, and all such different terms which we as medical students often get confused with. Okay, so starting first with association. So what is association? It is the linking of variables or finding relationship between them. I think we have covered a lot of this in the previous session, where we say that whether the smoking causes lung cancer, or whether green tea would avoid is associated with lower rates of fibroids, or things like smoking causes preterm labor or is associated with preterm labor. Now when we don't know something and when we want to do research, it will always start with understanding whether two things are related or not. Okay, if something is increasing or decreasing, is the other related to that? So the basic thing of whether want to find whether something is related to the other variable, not merely by chance, it is called as association. That is the very basic thing which we have been discussing so long. Okay. For example, as I told, if there is a association whether somebody is a medical student or maybe year of their medical, like of their MBBS, to substance use disorder, so that is called as association. Very often it can be done for binary as well as categorical or categorical variables. Okay, and for this we use measures of association, wherein we can use t-test, we can use chi-square test, we can use man-whitney test, or in the previous sessions, if you remember, if you have covered and attended and understood things like odds ratio, relative risk, and so on. All this what we call are measures of association, where we see whether one thing is related to other. Okay, but at the same time we have something related to association which we call as correlation. Okay, it is also related to linking of variables or finding relationship between them, whether they are related not merely by chance and actually there exists difference between two groups, or whether whether two variables are related or not. But the only catch here is uh, correlation can be done only for quantitative variables. That is, you cannot find correlation for when they are binary or categorical variables. Okay. Now we will come to in some time about what like how to choose a particular test. But essentially the difference between association and correlation is that we can do it only for quantitative variables, and the second thing is we can understand the strength of the relation between the two. Okay, in association we can just find out whether they are both merely by chance or not. That is like the higher the chi-square value won't tell you that whether it is stronger or not. It just tells you that the it is more significant. Okay, but in correlation it will tell you that if one is increasing by a certain amount, or how closely they are related. Okay, the strength by itself. Okay, so there are various measures of correlation. For example, we have Pearson correlation coefficient, we have Spearman correlation, then we have Kendall's tau beta or tau b, and so on. So these are called as the measures of correlation. These are also statistical tests by itself. But essentially, here I want you all to understand that when it comes to binary or categorical variables, we will often do association, whereas when they're both are quantitative variables. Now what is quantitative variables, if you all remember it, things like age, sex, bmi, or even your sugar levels and so on, or the amount of the quantity of sflt in your, or quantity troponin in eye, and so on. So when quantitative variables are there, we use correlation, and we have certain measures of correlation. Now, this is against regression. What does regression do? Regression, of course, it does the previous things as well. It does find linking of, it does find relationship between them, or does find whether there is a link between the variables. It also tells you the strength of it. But at the same time, regression also helps in predicting the value of a dependent variable based on the value of the independent variable. For example, you have in your OBGYN postings, you might have heard things like Hadlock's formula, where on sonography, it determines the estimated fetal weight, okay, based on the head circumference, the abdominal circumference, and the femur length. Okay, so this is kind of a regression. Or if other examples, if I have to give you all, tomorrow if I want to do a study where I want to see uh, how much weight loss do I happen to have based on 2 kilometers of walking per day, 4 kilometers of walking per day, or XYZ number of steps per day. Okay, based on that, I will do a regression analysis where I will come to know that if I walk so and so number of steps, I will gain so and I'm sorry, I will lose so and so amount of weight. Okay, so that what we do is called as a regression analysis. Okay, Now, this association, correlation, and regression are essentially statistical measures. Okay, these are what we do is statistical tests we apply and we find out that. Okay, but causation is something which is not only statistical but also logical and theoretical. Okay, now what do I mean by this? When I say that something is associated or something is correlated, or even if I find regression analysis of it, okay, that does not necessarily imply a causation. Okay, because in the previous sessions, you'll have learned about various biases, confounding factors, and a lot of other things, right? So essentially, if something is associated, it does not mean necessarily that it is related on a causative level. Okay, if I do a research, I can probably tell that smoking is associated with preterm labor. Okay, but if I want to say that smoking causes preterm labor, that there are a number of things which should also be present. uh, the more the better. Okay, to tell that this one thing causes other. Now, when I call these as things, what do I mean by these things? These are essentially the Bradford Hill criteria. Now, what are these? These are a set of nine. He called those as opinions, okay, or viewpoints. But later on, they came to know known as Bradford Hill criteria. Now, even in this, he did not mention this person named as Bradford did not mention all of the terms. Okay, these were added on later on, but essentially, what I mean is that this criteria help us to determine causality. Okay, whether something is causing the other thing. Okay, now we'll go through them one by one quickly. Okay, first one is strength. We know that association does not necessarily imply causation, but obviously, the stronger the association or the more the evidence for causation. That is, uh, if you find a correlation analysis, something having weak correlation, that is a correlation coefficient of 0.3 versus that of a correlation coefficient of 0.9, of course the one with the 0.9 would be more would point of more towards causality. Similarly, if you say in terms of p values as well, of course something with p value of 0.4, 0.04, it is still significant. Okay, but of p value of more than of p value of less than 0.0001, of course it is more significant, right? It is less, it says that it is less by chance. The probability of this happening by chance is very, very low. So of course, logically, if you think, it is related to causality. Okay, basically the stronger the better. Then consistency. Of course, I won't believe just one study saying that this causes this or this is associated this. I won't call it a causation. In fact, when you go ahead with your research careers, you will find out there are lots and lots of garbage papers also out there. No, with all due respect, there are a lot of garbage papers also there, which are not peer reviewed well and so on. Okay, but when the same thing is carried out by multiple other people, okay, the same studies happens over and over and over again, that tells you that this consistent results point out towards causality, that tells you about a causal relationship, which is also called as, if you remember, it was discussed in a previous session, external validity. A study's internal validity is by a study design, but external validity is by uh, doing the study again and again, causing it to be consistent and thereby causal. Okay, then specificity. Okay, if I tell you that smoking causes preterm labor, okay, but preterm labor is caused by a number of reasons. Okay, so if I do just one study about smoking and just say that it is associated, it might not be we might not believe that so quickly. We might want to do other things. We might have to check for other things. But when it comes to specificity, but for other example, if you say something like uh, maybe let me think of a example, but uh, maybe elevated Q-tropy is related to myocardial infarction. Now, of course, there are catches there also that there Q-tropy may be elevated in other false reasons also. But let's say it's highly specific. Okay, we'll come to that again later in diagnostics test part. But essentially, the more the presumed cause is to related to the effect. Okay, basically, if there are no other causes which we know or presumed causes is if we know, the stronger the evidence for causation. Similarly, temporality. Of course, the cause should precede the effect. If you say that preterm peli hua in a non-smoker, preterm labor, and later on the person starts to smoke, it is not exactly like good point towards causality, right? Again, that is not a perfect example, but still, if we say that mosquito bite causes malaria, of course the mosquito bite has to happen before the effect of malaria or whatever of its symptoms. Okay, similarly, biological gradient, or what we call as a dose response relationship. Greater effect is observed with greater exposure to the presumed cause. For example, if you drink more amounts of Coca Cola, okay, the amount of sugar which increases in your bloodstream, okay, which is the effect, should be more. That only then we could say that it is related to cause and effect. Otherwise we cannot call. In this example it is related, but in other examples it might not be. Similarly, plausibility. Can you think of a possible scientific logical explanation or mechanism of action where basically it is related to theoretical understanding by which the cause may lead to an effect? Okay, a lot of this happens, this studies or experiments or clinical trials which happen start with plausibility, where you first think about how it could happen, and then you go forward with the experiment. Similarly, coherence, that is, does the presumed cause and effect do not conflict with the scientific existing scientific consensus? Okay, similarly, experiment would tell whether empirical evidence supporting the presumed cause and effect is present. For example, animal studies or in vitro studies. Okay, this is self-explanatory, so I won't go talk a lot about this. And similarly, analogy, the presumed cause and effect should be comparable to a similar established cause and effect. Okay, so this is what is about causal relationships. Now, a few of practice questions. Okay, which of the following Brad Hill criteria is best represented when a study shows that the risk of preterm birth increases consistently with the amount of smoking during pregnancy? Risk increases consistently with the amount of smoking. Does anybody want to answer? You can just unmute and say.
B.
Exactly. uh, the answer is B, that is dose response relationship, because as the dose of the cause or the presumed cause is increased, that is amount of smoking is increasing, the effect, that is the risk of preterm birth, is increasing. So it is dose response relationship. Next question. A study investigates the relationship between obesity and gestational diabetes. The study finds a strong association between obesity and gestational diabetes, with similar findings reported in multiple studies across different populations. The relationships is consistent with known metabolic changes during pregnancy. However, study does not observe an increase in GDM risk with increasing degrees of obesity, as women with mild and severe obesity show the same risk levels. Which criterion is not supported by this study? Okay, so we can go one by one. You all can tell which there are a number of Bradford Hill criteria which are it is adherent to. So we can go one by one. So the study finds a strong association between obesity and GDM. What is the criteria adhered to here in this part? No, no, no. It is not. The question is different. The question is asking which is not supported. But let's not go there yet. Okay. Uh, Firstly, let's go one by one of what are adhered or what is supported. Okay. Strong association between obesity and GDM. What does this point out to? We can go back a little if you want. Which one of these? You can unmute and tell.
Strength.
That strength, exactly. Okay. Y'all can, by the way, take a screenshot of this slide because I like it's difficult to go back and forth. Okay. Uh, in now the say with similar findings reported in multiple studies across different populations. Now, what about this? What you can unmute and tell.
Consistency.
Exactly. This is consistency. The relationship is consistent with known metabolic changes during pregnancy. What does
The
this tell
biological
you?
plausibility is explained.
Exactly. Correct. And also about yeah, biological plausibility also, as well as a little of coherence also. Okay, but mainly plausibility. Then, however, that does not observe an increase in GDM with increasing degrees of obesity. Exactly like mild versus moderate versus severe. Now, that is those levels show the same risk levels. Okay, so what is not adhered to?
Dose response relationship.
Exactly. If there was a response relationship or a biological gradient, then mild versus moderate versus severe. Severe would have had more risk compared to mild obesity. Okay, so perfect. The answer is dose response relationship because the question was not supported. Okay, now uh, the next question, the study examines relationship between maternal age and risk of preeclampsia. The researchers find a significant positive correlation between age and preeclampsia risk, but they did not adjust for confounders such as BMI or smoking status. Which of the following conclusion can be drawn from the study? Anybody? Let's go one by one. Okay. Maternal age causes preeclampsia. Uh, we'll come to that later. Maternal age is associated with preeclampsia. Okay, I think that might sound because positive correlation is told now. Whenever there's correlation, there's definitely an association. Okay, so B might be correct. Let's see C. The correlation proves a causation. Now that is related to A, whether this causes preeclampsia. Definitely not, because remember, association or correlation is not equal to causation, especially where they have told you that they did not adjust for confounders like BMI, smoking status. So A and C are correct. Now, the D says that association controls for all confounding variables. The D is definitely not true because they have clearly told that it was not adjusted for. So the answer is B, where we can just tell that it is associated or correlated. Okay, so answer is B. Next question. A researcher performs a linear regression analysis to examine the relationship between maternal weight gain during pregnancy and infant birth weight. The results show that maternal weight gain significantly predicts birth weight. Based on these findings, which of the following can be concluded? Anybody can try, just unmute and tell. Anyone?
C.
Exactly. So the answer is C, because they have told linear regression analysis is showing that weight gain significantly predicts birth weight. Okay. But again, regression is also not equal to causation. Causation or causality is theoretical added to statistical. So here they have not told nothing about theoretical. Of course, we know that there are theoretical things which could we think of, but in the question they have not given it. So answer is C. Okay. Now, so Option A is wrong because causes what is there. Option B is correlated. Of course, like regression, when you say regression, okay, it actually tells you indirectly that correlation will be there. Okay, if it is significant prediction. But here the findings they have told about regression and prediction. Okay, so the better answer will be C. That is, I wanted to see whether you'll understand what regression is. Okay, now again D is not correct because causes what is wrong. Now, the coming to the next point, which test where? That is choosing statistical tests. Okay, I hope you all are comfortable till now. Okay, because now here I really want you all to focus on you know I to what all things I'm talking about, so that when you do your own research, you can like really use this part and choose the appropriate statistical test. In fact, while writing your protocol, because a lot of juniors come to me telling that they find biostatistics difficult, even at the protocol stage where like, where they have to just write what their plan is. Okay, so this will be very helpful for you all. I see Dr. Deepika's hand raised. Do you have a specific question?
Yes, is it convenient that I ask right now?
Sure. Is it about the previous part?
Yes.
Yeah, please do.
Yeah, I just wanted to confirm the utility of Bradford Hill criteria.
As in,
Like, where is this used?
basically it is not used in research per se, well, like, where you write manuscript, but it is used at a higher level while discussing guidelines, where basically when you want to come to a conclusion about findings of a research, or is one single research won't tell you anything. But when you bring all the evidence together and want to say that something causes something, that time we use such criteria. Again, one thing might not, one particular presumed cause effect relation might not adhere to all, but it is on us to decide that, or to check how many does adhere. And you have to use your experience and knowledge. You as in the senior researchers or stalwarts in the field do that. For example, years ago, we did not know smoking causes lung cancer. Okay, but then researchers started finding out that smoke, there is a higher incidence of lung cancer in people who smoke. Okay, they found out by prospective cohort studies. Firstly, they did a retrospective cohort, or they did case control studies. Actually, it began with case control studies. Then they did prospective cohort studies, and when a lot of studies came together, then people sat together and discussed this all is there. And it also does make sense, because the many studies are saying this, and it is found out only if a person is smoking before, and then is causing is having lung cancer later on. And if we can think of a theory also, that it might destroy and cause various biochemical stuff, I'm, again, it did not happen in a flow like that, but I'm just for the sake of saying, I'm telling you. Okay, so the point here is, yeah, it is used at a next stage after research is what I would say. Okay, I hope that answers your question.
Yes, thank you.
Yeah. So now coming to the next part, that is which test where. I have given you all the introduction of the topic. Now, why is this important? Because selecting the right test ensures valid and reliable results. Because each statistical test comes with a set of assumptions, comes with a set of parameters you have to adhere to for that test to be applicable. Because if you use a chi-square test for finding a relation between age versus age versus quality of eggs, okay, age versus quality of oocytes, that is not going to be a proper test. You'll not even get results for this example. Okay, so that's why choosing a proper test is important. Now, but how to do that? There are certain key factors to consider. That is, we should know about what data we are going to have. Okay, That is, we should first decide a questionnaire or your case record form, and or what are variables you're going to collect, and then you have to go to the statistical analysis plan. Okay, that is type of data you're going to have. Then the study design you are going to have. Okay, because if you remember this small thing, case control studies will give you odds ratio, and your prospective cohort or any type of cohort studies will give you relative risk. Okay, now this is a small example, but this applies in general to choosing a test. And your research question or your objective, with we have discussed that before, right? Association versus correlation versus uh, regression. Okay, these are three different things. Not, it is not exactly the same. So whether you want to find a relation, or whether you just want to find whether there is a difference between the two groups, or you want to predict, or you want to find a strength of relation, in such a case, these are the things to consider. Okay, now, first thing is type of data. I won't go into details of it because my colleagues have gone into details of it, but you all know that data could be categorical, that is qualitative, or numerical, that is quantitative. Categorical, in fact, could be nominal, gender, that is, or sex, male versus female, or yes, no, or ordinal, that is education level, like high school, bachelor's, middle school, or professional degree, or your Kupuswami scale, in fact, would be ordinal, wherein you have lower, upper, lower middle, upper middle, and upper, or something like obesity, mild, moderate, severe, and so on. Okay, where you can form a gradient, although you don't have a value, numerical value to it, but you have a gradient per se. That is called as an ordinal data. Then other part you have numerical, wherein it could be discrete, that is number of children. You cannot have a fractional or decimal number of children, or it can be continuous, height, weight, and so on. Okay, so this is types of data which you need to know and understand carefully while choosing a statistical test. Other test is, I think I yeah, other is firstly discussed about types of variables. Now, in this thing, you should clearly understand, and that has been discussed in the previous session, what is the independent variable and what is the dependent variable. Okay, what is the presumed cause effect relationship? Okay, what would depend on the other? And of each of it, you will have to know specifically. Independent is continuous or categorical, dependent is continuous or categorical. Okay, that is your uh, type of variable. Then you will need to know if you have groups, okay, in your independent variable. Okay, if you have groups, whether there is one group or two group or more than two groups. Okay, similarly for data distribution, I have discussed this previously, that you have to know what if the data is normal versus not normal. Now in statistical plan, when you write in your protocol, you wouldn't be able to know, because for knowing that you will have to perform the Kolmogorov-Smirnov test, or the other test I forgot. I usually do Kolmogorov-Smirnov. So you would be able to do only after you have data. So when you write a protocol, it's fine to write both the possibilities. Okay, so that's fine, but you need to know distribution of data. Why? I'll tell you later. And then you need to know the study objective. I have spoken about that before. Now, what are some common statistical tests? For continuous data, we have something like t-test, ANOVA test, Mann-Whitney U-test, Wilcoxon's signed rank test, Kruskal-Wallis test, and a lot of such tests. For categorical data, we have chi-square test, Fisher's exact test, and so on. Now, forget the descriptions about this, because I'll come to that in a quick while. Okay, but for now, I just wanted to enumerate those. Now, why and how, like how to choose the right test. Now, as I told, you need to know some certain parameters. Okay, uh, for knowing the choosing the right test. Now, even in statistics, like imagine, compare statistics to cooking. Okay, first you will want to, but the first step is knowing why do you want to cook. Whether you want to cook for yourself, because if I'm cooking for myself, if I am very tired, I will just cook Maggie. Okay. Whereas if you want to cook for your family altogether, or whether you want to cook for guests, because family you can cook ghar ka khana normal, but if there are guests you want to cook something special. So first step is finding understanding the objective or the research question. Second thing is identify your variable types. Okay, that is, uh, even if guests are coming, you have to know whether they are vegetarian or non-vegetarian, right? So that you will cook accordingly. Or if they have any allergies and so on, you need to know about the people you want to serve it to. Similarly, you need to know about the data type. The third thing is whether the data is normal or not normally distributed. That is, even if the guests are coming, you want to know whether they have any allergies, whether they have whether they come whether they like a certain, just like, two-course meal, or whether they would like a full course, with sweets and all, or what's the right taste. Some, if you have some foreigner guests, they might not like very spicy food, and so on. Okay. And the last thing is to define the number of groups. Whether only adults are come while cooking. Also, you will find out whether only adults are coming or adults as well as children are coming. Similarly, here you want to know what is the type number of groups coming and what is the type of groups they are coming. Okay, what we call as independent or paired. We'll come to that shortly. Now, why check for normality? Because statistical tests are of two types: parametric tests and non parametric tests. In parametric tests, those could be applied only and only for normally distributed continuous or quantitative data. Okay. Whereas non-parametric tests could be applied for qualitative data, or qualitative data converted to quantitative data. For example, if you're saying mild, moderate, severe, you can give it numbers still, okay, 1, 2, 3, and so on. Okay. Or non-normally distributed continuous or quantitative data. Essentially, what I want to say is that parametric is when only a certain specific assumptions are adhered to. Normally distributed, continuous quantitative data. Okay, basically the ideal scenario I told you. Whereas non-parametric test could be applied for anything else, including for normal distributed data. So basically, non-parametric tests are less nakras and parametric tests are more nakras, if I could similarly say in simple words. Okay, now we will start. Firstly, we'll check. Now, this flowchart which I'm going to give you all is more of a basic one, where I'll talk only about the normally distributed tests. And for each normally distributed test, you have, or a parametric test, you have a counterpart of a non-parametric test. Okay, so let's go. Variables to be compared, we have to check first. So it could be numerical. That is, you want to compare the means of it. Okay. Averages of it, means. You have discussed that before. Now, one possibility in that is that it could be two groups, or it could be more than two groups, or three or more than three groups. If there are two groups, we will use the T test. But if there are more than or equal to three groups, we will use the ANOVA test. Okay. Now, even in t-test, there are two possibilities where we have to ask ourselves, are the two groups, quote unquote, okay, groups, or the two things you want to compare, are they related or matched? That is it a before after comparison? That is, if it's an intervention study, if you want, or if it's an prospective observational cohort study, if do you want to see something of the same people, okay, of a, or if the same group stays the same, if you want to check in the same group before and after status and compare whether there's a difference. Okay, in that case, if your answer is yes, if there it is the same group which is coming, and we want to check at two different points of time, or two different conditions, the answer is paired t-test. Okay. But if it's not, then you call this as independent or unpaired t-test. Okay. So I guess you understood that. Similarly, for three groups also you can do the same thing. The only difference is It's called just called, if it's the same group, you will call it one way ANOVA, and if it's two different groups, you'll call repeated measures of ANOVA or MANOVA. Okay, so with an M, multiple ANOVA. So that's what it is for numerical or quantitative data. But if you want to measure, like, if the two things you have to measure are qualitative, that is yes, no, boy, girl, etc., between the two groups, there again the two differences whether you have a small sample size or a large sample size. If the sample size is small, you will use Fisher's exact test. Okay, but if you have a large sample size, you will just use a simple chi-square test. And I believe you all might have heard about chi-square test previously. Now, this is like, I just wanted to add that for the sake of the PPT. But parametric tests, I told you all about parametric and non-parametric tests, the basic understanding of it. But in essentially, in a parametric test, there are a number of things you have to take care of. That is, in parametric test, the population, you need to understand the population properly. Several assumptions should be regarding the population should be fulfilled. Otherwise, you'll get incorrect results. The distribution should be normal. The sample size should be large enough. uh, okay, these are the assumptions. But what is the benefits of parametric tests? They're easy to interpret, but the drawback is they're difficult to implement. I'm not talking about non-parametric tests because it's just the opposite of what I'm saying. Okay, yeah, just the point here is in non-parametric tests, the distribution can be anything. Okay, it can be non-normal, so that's fine, and it can work with small sample sizes as well. Okay, then parametric are more powerful and reliable because of course it's more like if you're doing a lab testing in very strict controlled fashion, right? You have control over a lot of things because assumptions are met. Okay, that's why it is of course more strong. But in non-parametric, it's less powerful. Okay, the results or reliability of it. Parametric always works with quantitative continuous variables. But whereas non-parametric को सब चलता है, it works, it's fine with anything. Central tendency in parametric test should be mean, and here in non-parametric is median. Of course, I told it normal versus non-normal. Outliers, parametric tests are affected by outliers. Okay, that's why you cannot use non-normal distribution, right? But in non-parametric tests, it is less affected. It's basically everything is related if you are getting the point of it. Null hypothesis in parametric test is more accurate, whereas in non-parametric test, it incorrectly rejects the null hypothesis. That is, there are strong chances that your test will show significant in spite of not being significant. Okay, what we, if you remember, is called as the alpha error. Okay, type 1 error. Then examples I have written Z test, T test, ANOVA, etc. for parametric, whereas Wilcoxon, Mann-Whitney U test, Kruskal-Wallis test, etc. for a non-parametric test. Each parametric test does have its non-parametric counterparts, so it's kind of easy to just remember how to use the parametric test and then find out the analogous non-parametric test for it. Okay, so that's what I was coming to here, that uh, this is the major mega table which you can refer to later on, and credits to this is to Dr. Urmila Thatte, Dr. Nitya Gokte et al, where you can just check your firstly at the top is your type of data, and at the left is your what objective or what groups you have. Okay, so doing that you can just find out your proper test. So here you can see one sample or PET T test has its non-parametric counterpart as Wilcoxon. On PET T test, non-parametric is Mann-Whitney U test, and so on and so forth. Okay, so the point here, the star marks here, I'll explain that here one way ANOVA, here what, because it any type of ANOVA or Kruskal-Wallis test or Friedman test, because it is comparing three or more groups, there is something called as a post hoc test, wherein after this preliminary analysis, okay, using ANOVA or whatever, you will do further analysis to find out which of the groups is more better, okay, or which of the groups is causing that difference. Okay, that is called as a post hoc analysis. Here, Fishers versus chi-square, you all know I told. Smaller sample size is Fishers and greater is chi-square. And about odds ratio and relative risk, you all definitely more than know that, know more than me, because of the previous sessions, that odds ratio is case control, whereas relative risk is cohort. Okay, now coming to the practice questions. Okay, so here the question is asking, a researcher is comparing mean hemoglobin levels between two independent groups of pregnant women, one with unsupplementation, other without supplementation. Which statistical test is more appropriate to compare the means of two groups? Okay, we'll go back and we'll just use this. Okay, sorry. Okay, so your what are the variables to be compared? Anyone? Hemoglobin. So is it numerical or is it categorical? Hello?
Numerical.
Numerical. Perfect. Okay, numerical. They want to compare how many groups? They told one with unsupplementation, other without, right? I guess. So how many groups?
Two.
Two groups.
Two groups. Perfect. Now, what we now come to know that it is definitely t-test. Okay. Uh, are the two groups related, or is it is not the same group being iron supplementation and then you want to check? Okay, here they want to check two different groups where one already has iron supplementation, one does not have. So are they related or matched? Tell me.
They're independent.
Not related.
Yeah, they're independent of each other, they're not matched, so independent t-test. Perfect. The only catch here is that you will have to check whether the hemoglobin level values which you data you have is normally distributed or not, because if it is not normally distributed, then you will just do instead of unpaired t-test, you will do a man whitney u test. Okay, simple. It's just a analogous thing. Fine. Then, so answer is independent t-test, or if not normal distributed, you'll do man-Whitney U test. Okay. Now, a study evaluates the association between mode of delivery. Okay. I will not go to the thing now or the flow chart now. Now tell me, what does this tell? How many groups? Mode of delivery. Okay.
Is it four?
No, like just two groups, vaginal versus cesarean.
Two
Na?
groups.
Yeah, yeah. Two groups. Okay. In the independent variable, versus incidence of postpartum hemorrhage in sample of 200 women. Both variables are categorical. Now they themselves have told categorical. Now incidence, they're not going to term like incidence is a yes no question, right? In totality, you will find incidence in terms of a number, but for a particular woman, PPH plus minus ही होगा ना, like whether she has or doesn't have. So yes no. So which statistical test will you use? Tell me, both are categorical, right? So the right side of the flow chart. Okay, I'll just go. So the here. Now tell me, what sample size did it tell? 200. 200 is the last sample size. Here the demarcation is 25 or 30. If it's less than 25, 30, it's small, then more than is large. So the answer is a chi-square test. Okay. Okay, the next one. Study measures change in systolic blood pressure in pregnant women before and after administering new hypertensive drug, antihypertensive drug. Same women, okay, same women are measured before and after treatment. Which statistical test to determine significant difference? Anybody to answer? You can just
No.
answer.
PAT.
Exactly. PET test, because uh,
Two groups, right?
yeah. So here there are two groups. The same, they are matched. Okay, but there are only two groups before, like technically before and after, right? So it has to be two. So it is definitely a t-test, and because it's the same, it is paired. Okay. ANOVA would have been the same answer if it was like, before versus after 2 months of treatment versus after 4 months of treatment, something like that. When you have three, right, groups. So yeah. Next question. Somebody wants to try? A researcher wants to determine whether there is difference between median duration of labor between three different groups of women receiving different types of labor relief: spinal, epidural, and no analgesia. The data are normally distributed with statistical test.
ANOVA.
ANOVA.
Perfect. It's ANOVA. Does anybody want to explain why? Anybody? Just yeah, Dr.
Three
Deepika.
groups, numerical data.
Yeah, it is numerical data about duration of labor. Okay, whereas epidural versus spinal versus no analgesia is three groups,
More
right?
than equal.
Yeah, more than equal to three is ANOVA. Okay, but here even if they said mean, okay, the thing is here there is a catch that they want to come the difference in median. Okay, so if this statement was not given that it is normally distributed, okay. Actually, the thing is, I forgot to change the word mean. Very honestly speaking, the question initially I made was median and not normally distributed. In that case, the answer is Kruskal-Wallis test. Okay, but I thought let's make it easier. So, but I forgot to change here to mean. So, mean and normally distributed tells that it is normally distributed. So, it is ANOVA. If it is not normally distributed, the answer would have been Kruskal-Wallis. Similarly, in this test, it would have been in PET-T test, it would be Wilcoxon sign rank test as a analogy to PET-T test. Now, you don't need to remember. I remember because I did not learn it, because I have done like these things over and over again, that naturally now I automatically remember stuff. Okay, so this is done. The last question, if anybody wants to try, it's a simple one, or like it is related to the previous starting what we discussed. A study investigates whether gestational age is related to birth weight by examining the linear relationship between two continuous variables, two quantitative, and they want to find the strength of relationship. What is the statistical test now, or the statistical method, I will say? Okay, no, see, both are quantitative. Both are not categorical. Both are quantitative continuous. So go to the very first slide I showed you all about association versus, what was it? Anyone?
Correlation.
Exactly. So answer is correlation. Now, I purposely kept this question so that we could go to the next topic of correlation analysis. I hope you all are with me till now, and we are already 1 hour down the time, and I am a bit scared about overshooting the time. I'm telling you all before that, but again, like I hope you all are understanding and you all are hooked on to this session, and you all are enjoying it and understanding it well. A few yeses might be helpful for getting the vibe up of this session. Are you enjoying? Okay, thank you so much, Vamsi Dharan, for the thumbs up. Thank you so much, Dr. Deepika. Okay, all right, let's move on. So, what is correlation? I told her a correlation analysis. Correlation measures the strength and the direction of linear relationship between two variables. Remember, strength and direction. Your association will not do that. Okay, it won't tell you the strength that properly, but also it will not tell you the direction. Okay, if one is increasing, other should decrease, or so on. Okay, so that brings us to types of correlation. A correlation could be positive, that is, when one variable increases, the other also increases. In that case, we call it as positive correlation. Whereas, if one variable is increasing and other is decreasing, It is called as a negative correlation. I'll give an example. For example, let's say uh, with uh, increase in wait a minute. Uh, for positive correlation, I'll just tell simply about in diabetic people. If they eat more sweet, their HbA1c would be higher, or the blood sugar levels will be higher, right? So, the amount of sweet in grams is positively correlated with your blood sugar levels or blood HbA1c level. That is what we'll call it positive correlation. But what is negative correlation? Now I'm I have been doing research. I could tell openly that about vitamin D levels and fibroids. Now it is known that for people who have higher vitamin D levels or sufficient vitamin D levels, the incidence of fibroids in them, or the prevalence, or even the size of fibroids in them is lesser, is smaller. Okay. So, as the vitamin D levels in the body, or serum vitamin D levels goes up, the size of fibroids goes down. So, that is about negative correlation. Okay. And no correlation is when there is no consistent relationship between the variables. Now, how do we measure this? What now essentially happens that your computer software will do something called as a scatter plot, which I'll tell you in later on, and find out something called as a correlation coefficient. Now, this correlation coefficient has both positive and negative values, okay, which range from -1 to +1. That is 0 in this case is the baseline. Okay, if the R is perfectly 1, that is +1, we say that it is perfect positive correlation. That is, it is so strong that, like, when one increases, the other will definitely increase. I'm not telling how much it will increase. I'm saying it will definitely increase. Okay. Whereas if the R is -1, we can tell that when one increases, the other variable will definitely decrease. Again, I'm not telling about how much, by how much it is increasing or decreasing, because that comes about regression. Okay, that is the difference. This will, your correlation coefficient will just tell you about the strength, not tell you about how much or the prediction of it. Okay, but it will tell you the direction, because plus and minus are there. Farther the value from 0, stronger the correlation. Now again, there are no specific cutoffs per se, but in general you can use, say, something like till zero point 0.3, you will call it a weak. That is plus minus zero point 0.3, of course. Zero point 0.3 to zero point 0.7 is moderate, and zero point 0.7 to zero point 0.1, sorry, 1.0 is a strong correlation. Okay. Now here I'm telling you that 0 is the baseline. That is, if I want to find confidence interval, or something like that. Okay, when I do a meta-analysis of correlation coefficients. Okay, my confidence interval has to, if it has to be significant, if p value has to be less than 0.005, sorry, 0.05, then it should either both the lower and the upper bounds of the confidence interval, I told you in the previous session, should be on one side of the zero. Either both should be positive or both should be negative. But tell me, as a small reminder or revision, similarly, what is the baseline for odds ratio and relative risk? Here I told you 0 is the baseline. What about odds ratio relative risk? What is the baseline? That is, you will call as nothing specific. There is no difference. Anybody?
One.
Exactly. For odds ratio and relative risk, it is 1. Whereas for correlation coefficient, it is -1 to, sorry, it is 0. Okay. That's why you have negative and positive values here. But whereas there you have values less than 1 or more than 1, and that's when you tell, right, whether one is increasing the risk or decreasing the risk. Okay, so that's about it, about correlation coefficients. Now again, here, if there are if there is a relay, if you want to find out in normally distributed, it is Pearson's R. But whereas if you want to see about ordinal data or non-linear relationships, you will find out the Spearman's rho. Again, it's similar to parametric versus non-parametric. Now, about scatter plot. So that's what I told you. The statistical software, or you, previously what people used to do is manually they used to do is they used to plot along the x-axis one variable and y-axis the other variable. Okay, and in that they used to plot for each data point or one single data entry, one single person. Let's say amount of cake consumption in grams, okay, versus the sugar level of in the body. They used to plot similarly how you do in any of your graphs, what you have done from standard fifth or grade fifth, right? So you'll keep on pointing all the different graphs. So you will find out one of these scatter plots. As you can see, if it is like randomly in the center of the screen, I believe you all are able to see my arrow. If they're randomly plotted, you cannot find a line which passes through those points. It means that it is not correlated. Whereas if you find something like so closely packed and going in a single direction, you will say that, and see, the slope of this line is positive, right? It is upslanting line. So it means that the correlation coefficient is positive, because correlation coefficient is essentially the slope of that line which passes through those points. So if they're so packed tightly together, it is a strong correlation. Whereas in this graph, you can still probably make a line through those points, but it is not that strong. Like logically, if you think so, it is a weak positive correlation. Similarly, on the other hand, except that the slope is down slanting, so it's a negative correlation. Now coming to a few questions. A study investigates the relationship between number of prenatal visits and birth of infants. Okay, birth weight of infants. Pearson correlation coefficient is calculated to be 0.65 with a p-value of 0.01. So it's less than 0.05, right? So it is significant and it is positive, and it's 0.65. So what does this result uh, imply about relationship between the number of prenatal visits and birth weight? Firstly, do we call it? Firstly, we have to check whether it's significant. Yes, it is significant. Okay. Now, whether it is positive or negative. Okay. So it is plus, right? So it is positive, and it is falling between zero point 0.3 to zero point 0.7. So it is moderate. So the answer will be there is a moderate positive correlation between prenatal visits and the birth weight of infants. That is the higher the number of prenatal visits, the higher the birth weight of infants. Now tell me, if somebody wants to try, is this a causal relationship? Like by logic, you can tell. Does prenatal visits automatically would cause birth weight of higher birth weight of infants? No, right? But the thing here is prenatal visits would cause better healthcare, better antenatal care, which in turn would cause less incidence of lower birth weight babies, and that's why basically higher birth weight in short. So that's why more number of ANC visits would cause more, sorry, would be associated. See, even I messed up here. Would be associated or correlated with higher birth weight of infants, not causative. Okay. Next question. A study examining relationship between maternal hemoglobin levels and risk of preterm birth. Okay, a Spearman correlation coefficient of minus zero point 0.4 is found. Which of the following best describes the relationship between the maternal hemoglobin levels and risk of preterm birth? Tell me if somebody is here, like, somebody wants to answer.
B.
B. That's a correct answer. Can you explain why? Like how I did for the previous one?
Yes, sure. Uh, it is minus zero point 0.4 that is between the moderate level of correlation,
Yeah.
Yeah,
So
and the
going
negative
for,
sign indicates negative correlation, so that makes
yeah,
it moderate negative correlation between the variables.
yeah. So, and it is negative. So as one increases, the other should decrease. And that's what the second option was telling us. Is that correct? Yeah. So, oops, I think oh, I kind of labeled the slides opposite. But that being said, I hope you all are with me now. So let's go to the most exciting part of this session, which is the demo of the computer statistical software. Now, I just want to know how many of you all are going to like have downloaded JASP in this group. You all can raise the hand. Others also, if you all have. Nice, Dr. Deepika. Thank you. Great, Astha. Great, Shashank. That's perfect. So, I the thing is, I will have to rush through this part a bit, but you can always, if you have other recordings, so you can always go back and try. Okay. I'm going to do this, but like if at all, if your doing pace does not match with mine, please bear with me because you're already above and beyond the time. Okay. So I will stop presenting at this point, and I will share my screen. Uh, screen, entire screen. Is my screen visible now? Perfect. Sorry for that infinity loop. So when you open the software, this is JASP. So welcome to JASP, and a lot of people use SPSS, and SPSS is more, cliche, or let's say stereotypical software which people use. But honestly, I like JASP more because one, SPSS is paid, JASP is free. Okay, totally free. And JASP has a much better user interface, so compared to SPSS. For the matter of fact, the results what you'll get in SPSS, okay, don't I'm not defaming any just for legal reasons. I'm telling, I'm not defaming, I'm just putting my opinion of why I like JASP software. And all right, so uh, all the examples have made are related to OBGY. Okay, so just let me put them on my home screen. Say hi to my sister on the screen. Uh, I'm kind of sick, so I have come to my aunt's place. So I'm using her laptop because during the last session, it was hanging a bit. So, anyways, so these are the particular sets. So practice data set, and it's going to be for y'all. Instructions also for y'all. This is for okay, all right. So let's open the first one. Okay, this thing I'm doing because y'all want y'all to know how to do even conversion to CSV. So the point here is JASP does not, uh, you know, directly take on Excel sheets. Okay, because it needs only a single sheet with all the fancy features of this fancy features of Excel gone. Okay, so when you use enter your data in your Excel sheet, firstly, your first thing will have to be that all your values or in each particular row, so in each particular column have to be same. That is, even if your male is like this and female male versus female hai na, so if your male is like this, whereas if you type the other male as MALE, that is this with a small m, or if you type the third one as MALE with a space, that won't work because your SPSS or your JASP will count them as separate entries altogether. So what's better to do is just copy paste this mail, copy. And if you're using a Google form to take the data, that's that kills the difference between the two group. That uh, you know solves the errors. Okay. But if you're manually typing from the data you collected from field on paper, you'll have to take care of that. Okay. uh, or the other option which previously people used to say when they used to use SPSS, because SPSS initially used to take only 1201, like in terms of numbers. So which is not the case now. Even SPSS uses takes on word data, worded data or textual data, and even JASP. But again, the catch there is you will have to have uniformity in your answers, sorry, in your data, and so on. So this is one sheet I took from my previous study on screen addiction, your phone, laptops, etc. And only this is the only non-OBGYN one. Okay, so versus this is the DAS score, that is digital addiction scale score. Okay, and so according to that, we've made them into groups. That is test versus control, where the test is those who had higher, like those who are addicted, versus controllers, those who were not addicted. And to check between all of this, that is aggression, loneliness, sleep, and so on and so forth. Now the first step to actually analyzing is you click go to files and save as, and click on desktop, and I mean wherever you want to, and save it as a CSV file. Okay, remember CSV file, and click on save. Now I already have it ready, so I won't do that. But essentially, it has to be converted to a CSV. I'll do it for the sake of the discussion now, because it I want to show you that when you do this type of error or whatever, not error but a dialog box comes. Basically it will save only the main sheet which is open, and if you want to save all the sheets you'll have to do it individually. Okay. Because while inputting into JASP, it will take only one single sheet, and it will remove all the data formatting and all of that. Okay, click OK, and then it will be saved. So I'm not saving them now. Don't save. Okay, so going to JASP, the first test we'll be doing, and also the frequencies and stuff, is oops, sorry. Then you go to main menu, you click on open. Okay, then computer or wherever it is. Okay, basically browse and open the so sample data set screen addiction for chi-square test. Okay, now this is how you will find the first row will automatically go up, and then each data entry will be so on and so forth. Okay, so this is good. Now firstly we'll do descriptives, that is if you want to find out your mean, median, mode, and all of that. Okay, and your tables. Okay, so when you go to this, now I want to find out mean, median, mode, and everything of everything, so I'll just go on clicking everything. So now here you can see this has gone here. So they will also tell you if there is any missing data. Okay, if there is some cells you forgot to enter and so on. Okay, now in statistics, if you want to remove the missing, just basically here now the results will be shown, and you can adjust whatever you want to skip. Now of course for sex, which is qualitative, they won't give mean because it's not possible to calculate that. But for all the continuous variables, as you can see, age, the dash score, now ideally, now as I told in the previous one, dash score is is not normally distributed, because it is a qualitative data compared converted to quantitative, right? Because screen addiction score is not a physical value, right? So here it is more appropriate to use a median, and which is what I clicked here. I hope you all are able to see the screen, and I would like if you'll unmute and tell, because I cannot see the screen now because I've shared the screen. Are you able to see?
Yes, yes, yes.
Perfect, perfect. Okay, so here you will be able to see median, standard deviation, minimum, maximum, coefficient of variance, interquartile range. Now, When I say interquartile range, usually we state the 25th and 75th percentile, right? With along with median. But in this software, if they want to say interquartile range, what they will do is they will do the minus, like 75th percentile minus the 25th percentile. That is, they will give the range value. But if you similarly for range, okay, they will give the minus करके value. But if you want to find the individual 25th percentile and 75th percentile, what you just go is confidence interval for mean with 95%, then it will give you the 95% confidence interval, upper and lower. Similarly for your this for your percentile 75th and so quartiles you will select, and they will give you 25th percentile. 50th percentile is your median, so not a problem about that, and 75th percentile. Similarly, if you want to check the skewness or using a Shapiro-Wilk test, then you will also get that. So Shapiro will test, and it will tell you whether it's like significant or not. So here you can see Shapiro will test is telling you it's less than 0.001. So age was normally distributed. In fact, dash score was also normally distributed by terms of values, but by theory, dash score can never be a Gaussian distribution because it is not a physical value. Similarly, for depression, anxiety, stress scores, although the test value is showing significant, but still you cannot use because it is essentially qualitative data converted to quantitative. Okay. Similarly, if you want to find the cut points for whatever percentiles, basically here you can do whatever you all want. Okay, cut 4 percentiles. See, now you can see double of everything. But if you want to see 5 equal groups, that is, you want to see 0, 20, 40, 60, 80 percentile, so I'll put 5 here. So you can see that's the thing. But if you want to find a specific percentile, let's say 78th percentile, you want to know. So 78th percentile, it will give. So basically, you can, like, when you open the software, you can do what, like, try to be crazy and do whatever. Okay, you all want. Now, similarly, you all can do distribution plots and Likert plots and so on. Tables, frequency tables, you all can find out. For see, for age also it gave. Okay, then female, male, it also gave, like, in terms of frequency, percentage, and so and cumulative percentage. So for uh, control and test also it gave aggression, loneliness. For basically for qualitative variables, if you want to find the percentage and frequency, go to tables and click on frequency tables. I hope this is understood till now. Similarly, you can find out plots also. Okay, but like, you can experiment with the software later on. Okay, this is now done. I'm just erasing it for the sake of keeping it clean. Now, if we want to do a chi-square test, okay, in that case, we will have to go to frequencies and click on contingency table. Okay. Now, initially, I want to check whether there's a relation or association between sex and aggression, loneliness, depression, and all of this. Basically, all the qualitative data. So again, I'll tell you, wherever they have used this scale now, it is a quantitative data, and wherever they have used this three circles, that is a qualitative data. So you will easily come to know even if you don't remember your own table. So I want to compare row sex, okay, with, I want to compare it with aggression. I want to compare it with loneliness. I also want to compare it with depression, anxiety, stress. I also want to compare it with dry eyes. I also want to compare it with BMI interpretate, like BMI groups. So as you can see here, you will get your test wherein you will have your, like, groups and table, and you will find your chi-square test. See, you can see the value here. You can, it's, so this is this is not the actual study data. This is I made for just for the sake of this session. So 0.09, so it is not significant. Similarly, it will give you all the possibilities, even for multiple groups. Now chi-square could be done for multiple groups also, right? okay, there is no different test for more than three groups. So for this also they found the value, chi-square test value as well as the p value. So it's that easy. Okay, it's that easy. Similarly for this one, okay, and in this case, if you want to find out odds ratio also, that also they can find out. That is, if you want, if you're doing a case control study and you have the groups. In this one, it was not a case control study; it was a cross sectional study. So odds ratio is a wrong thing to say, but they will, like, if you click on odds ratio, they will give you odds ratio also, and if you basically unselect the odds log odds ratio, then you will get the actual odds ratio. Don't click on the log one because it will give the logarithmic value of it, and so on and so forth. Now, just to make sure that you all are attentive, tell me the odds ratio here was is shown as 1.94. Okay, so but the p value is 0.117. Tell me what is the interpretation of it. It is related to aggression and male female. Okay, let's take some other. We'll take here. Anybody? Just anybody. Now see, if you the two groups are like, actually instead of doing sex, I should have done off, addicted versus non-addicted, right? Because that was the purpose of the study. So you can see this was the value found. So here by this I would interpret that there is a significant difference between two groups, that is addicted versus non-addicted, for aggression. Okay, similarly for odds ratio, if I find out that it is 4, so the I would say that that uh, the odds of being screen addicted is 4 times higher in those with aggression compared to those without aggression. Okay, so that is how you find odds ratio. Okay, now I hope you all are with me till now.
Yes, yes.
Perfect. I'm going a bit fast with this because honestly, you can see it's quite easy. Just like clicking, and just using your, like, keyboard and like experimenting with it. I am able to do it fast because I have experience with this software. But even you all will gain speed gradually. Now, okay, I will open now for the next assignment. What I will do is I want to do a Fisher's exact test. That is for a small, sample size. So I have a separate data set for it. So imagine I want to see the association in a cross-sectional study, that whether smoking is related to preterm labor. So I find, and I cannot find a lot of people. I do it as a pilot study, and I find out only this many people. But the way of doing it is similar. Go to frequencies, go to contingency tables. In one rows you will have smoker versus non-smoker. In the other you will have columns as preterm labor, yes or no. Since statistics they are giving chi-square test, amazing. Okay, now if you want to exactly find out whether for Fisher's exact test, you will have to click on odds ratio. Okay, even if that's not your purpose, and it will give you the Fisher's exact test value. Okay, and odds. So the odds ratio here, see, p value is the chi-square test is giving you a p value of 0.025. So you will think that, oh, this is less than 0.05, so it is significant. I mean, in this study, I'm talking pilot study. But when you do the Fisher's exact test, you will find out that the p value is 0.07. That is not less than 0.05. So it is not significant. Again, we know that it is associated, but from this data I'm talking about. So that's why you want to be sure and careful about which test you're using. Okay, I hope this makes sense. Now, let's do another assignment. Okay, so let's do Fisher's is done, chi-square is done. Let's do unpaired t-test. Okay, so in this study. Uh, Let me open it. So imagine if you're doing a study about you want to see whether GDM is related or associated with a higher birth weight. In that is, we know now that GDM causes macrosomia and large weight birth weight babies. But imagine you did not when you wanted to do the study. So I did like imagine we did a study where we compared the two groups, no GDM versus uncontrolled GDM, of course. Controlled also, if you do intervention at an early stage, it won't cause no macrosomia, but no GDM versus control uncontrolled GDM. And we check the birth weight in grams. Okay. Okay. Now, in this case, if you want to do, first tell me whether you will do a unpaired t test or a paired t test. Tell me whether the groups are related or not. Is it before, after? Anybody?
Unpaired.
Perfect. It is unpaired. Uh, So we'll do unpaired t-test. So you will go to t-test and you will go to independent sample t-test, and where your dependent variable would be birth weight and grouping variable or your independent variable will be GDM diagnosis. And if you just put simply, it will simply give you the t value as well as a p value. Okay. Again, now because I just made up this example, so see, it is also telling you that this data is suggesting a violation of equal variance assumption. Basically, it is telling you that the data is not normally distributed and so on. And so essentially, we should have used a Kruskal-Wallis sorry, on petty test. Yeah, we should have used a Man-Whitney U test. So let's go back and let's use a Man-Whitney U test. So yeah, no error is shown. So but still it is finding out significant. So using this, essentially in JASP, even if you want to do the non-parametric test, the option you have to at the top you have to select the parametric test only. And once you go to the particular one, you will find out that you have the option of, so student t-test is basically your normal, like t-test, but when you use the Man-Whitney U test, it is for the normal this not normally distributed thing. Okay. Similarly, if you remember, like in the last thing I told you about one tail test and two tail test, that also you can do. So now I want to say that I want to understand whether it is specifically causing higher birth weight. Okay. So here I will select group 1 is more than group 2. Now what is group 1 and group 2? For that you will have to click on here. Okay, go back, click here. Whichever is mentioned first is group 1 and whichever is mentioned later is group 2. Okay. So now it is saying that it is significant that no GDM is less than group uncontrolled GDM using the Man-Whitney U test. Perfect. So this is how your t test. If you're using a pet t test, that is your for your as I told, for whatever, like for your paired, or if you want to do before after, or if you're using a matched groups. Okay, if you're using matched groups. Okay. Now let's just do one more, that is for ANOVA. Computer browse, I have one. Now for this, okay, let's first do Kruskal no, let's do ANOVA. Okay. So imagine I'm doing a study where I want to check whether socioeconomic status is related to mean daily calorific intake of the participant. I do the study and I do collect a large number of sample. Okay. In this sample now, I find out that it is normally distributed. Okay, I have done the test before. Okay, and so why will we use ANOVA? Because Kupuswamy gives you 5 classes, so that is the 5 classes which I found out. Okay, after doing the preliminary, the scores of MKS, and I found out the classes, and I have the data of the calorific intake. Now I want to see whether there is an association. Now, because this is more or equal to 3 groups, Okay, we'll use ANOVA, and because this is normal distributed, I'm telling you all, let's assume that. Okay, so now you will use ANOVA. Basically open ANOVA and click on ANOVA again. Okay, in your dependent variable, uh, calorific intake will come, and your fixed factors MKS will come. Okay, it is taking some time to load the results. So yeah, so we have the value and you have the p value. Perfect. So that is how your ANOVA is done. And one last example, if you all are observing, I'm not doing anything, I'm just clicking on numbers. There is nothing very complicated in this. Okay, as for the last example, for a non-normally distributed data, I have imagine I'm taking an OBGYN quiz, and I'm recruiting participants from all the years of medical school, or let's say even I'm doing the quiz between you all, and the score on the standardized OBGYN exam out of 100 is whatever. Now, essentially, score is not a physically measured parameter, right? And also, it is not continuous, obviously. Uh, right? So, it is because so it is a non-Gaussian data or a not normal distributed data. Okay. So that's why what you will use a non-parametric test. But now you have more than two groups here. Okay. So if it were normally distributed, what I would have told is use an ANOVA. But because it is not normal, we will use a Kruskal Wallis test. For this also you go to ANOVA. Okay, and you will there are so many options here if you see, and essentially the value they then you will go to here, you will put it here, this you will put it here. Okay, so the value it will give you automatically, it will give you using your this uh, using your Wallace tests. You don't have to do anything over and above what you're it the software understands by itself. But if you still want to do the assumption checks, you will do the assumption checks. And actually, again, that was a small mistake by me. It is showing that assumptions are met, so that's not a problem. I told you all, if you'll remember, that whenever you use ANOVA, you have to do some post hoc test where you will understand that which is higher, which is lesser. So that you can put here, and it will give you comparison of first versus the other three, fourth versus the other three, and so it is comparing a family of four. So again, I won't go into the details of it because it is quite a lot. So, but this is essentially I want to tell you all is all of this is possible when you use JASP. Now, I haven't made an example of correlation analysis, so pardon me for that. So, but I hope this is understood. And after this, you know, after this session, I will send this practice data sets and instructions for you all to practice at home. So I hope that helps you all. Okay, so do try, and let me know whether you all are able to do or not. Okay, so I will stop sharing now. Uh, so just one last topic. I'm a bit conflicted here about whether we should do it now or maybe we can fit it in one of the later sessions because we're already at 8:45. Rajvi, do you have any particular opinion about this?
What topic do you want to cover?
No, the sensitive diagnostic tests.
Which are you think like it has already gone 45 minutes about
Yeah,
time 46.
yeah, exactly. So maybe we could skip that for now, and we could we can try to cover up in the one of the further sessions probably. What do you think?
Sure.
Yeah. Okay. All right then. Sorry for taking this much time. Like, this is against the plans what we had thought. But all the participants here in this session are full course participants. So obviously, you all have access to the further session. So we can, uh, you know, uh, we can take that in the later session. Okay. So I think that was all for now. We will. Yeah. So for the uh, post event form, we will send an email later on. Okay. We won't don't fill it right now. Okay. uh, uh, Again, Rajvi, could you just delete that message? But uh, we will send the post event form later on. Please don't fill that right now. So we'll send that through your emails in the same email which like no, sorry, we'll send a separate email. But I hope this session was helpful. Because now we have 15 minutes, like not exactly 15 minutes, above and beyond the 40, like 45 minutes more than the decided time. But still, if you all have any particular questions, please feel free to ask. I could take a few couple, 2 to 3 questions. And in the meanwhile, it will be awesome if you all could, turn on the camera and, we could take a screenshot for, memories. Can you please turn on your cameras? Hafsa, Vamsidharan, K. Gomti, and others. There are two more, I feel. Aarti and J. Navin Kumar. Can you please turn on your cameras? All right. People are leaving, so I'll take the screenshot like this itself. Again, thank you so much for joining in, and I'm talking and taking the same time. So again, thank you so much for joining in, and I hope you all like this session, and hoping that we see your participation in the further sessions as well. And thank you so much again to Rajvi for helping me with this session and recording. And yeah, this was my last session for this series, but we have some amazing sessions in the further part of the series, and you all will totally enjoy that. Thank you so much again. Y'all are free to leave the meeting if you all want. And if you all have questions, you're free to ask as well.
Thank you.
Thank you.
Thank you.
All right, let's end the meeting.